Hello, welcome to my YouTube channel. Today we are going to talk about physical quantities, which is usually the first chapter in most high school physics lessons. And in today's lesson, we're going to explain the meaning of physical quantity, do a little exercise to test your understanding of the meaning of physical quantity, talk about the different types of physical quantities, discuss briefly the different system of measurement that are used to define units of physical quantities, and then we'll talk about the 7 base quantities under the SI unit system and do a little exercise to test your understanding of the base quantities and how you can distinguish them from the derived quantities. Meaning of physical quantity. One of the most crucial things to scientists is measurement. Among the many reasons why measurement is crucial to scientists, measurement allows scientists to quantify observations. Imagine observing that someone is warm. How can you quantify the warmness? How warm is warm, or how hot is hot? But if you have a thermometer, you can actually measure how hot the person is. That is what nurses do in the hospital. Imagine a nurse placing an infrared thermometer close to a patient and sees the value on the thermometer 38 degrees Celsius. 38 degrees Celsius represent what we call the temperature of the patient. The warmness have now been quantified. You now know with absolute certainty how hot the person is. This is a reliable result that a medical doctor can work with to help him diagnose what is wrong with the patient. What then is a physical quantity? A physical quantity is any physical property of a substance that can be measured and expressed as a product of a number and unit. From the definition, a physical quantity, number one, is a physical property. It can be measured, can be expressed as a product of a number and a unit. So the nurse used the thermometer to obtain the temperature of the patient as 38 degrees Celsius. Is temperature a physical quantity? To answer this question, we are going to examine the measured temperature of the patient's body in the light of the definition of a physical quantity. Temperature is a physical property of the patient's body. Why? Because we can use it to describe the patient's body. Temperature can be measured using a thermometer. The measured value of 38 degrees Celsius has two parts, 38, which is a number, and degrees Celsius, which is a unit. So, temperature is a physical quantity. Let's take another example. Time for a complete rotation of the Earth about its axis is 24 hours. Is time a physical quantity? We can use time to characterize the Earth's rotation. So, time is a physical property. Time can be measured using different instruments. Examples include watch, stopwatch, etc. The time measured as 24 hours has two parts. 24, which is the number, and hour, which is the unit. So, time is a physical quantity. Okay, so it is time for our first exercise. The task here is very simple. I just want you to think a little bit and insert the right physical quantity in the blank space. After 30 seconds, I'm going to come back and insert the right answers, and you can compare with yours. Okay, time up. Check the answers and give yourself a score. If you have all correctly, congratulations. If not, don't worry. By the time we finish the chapter, everything will become very clear. So far, we have seen quantities like temperature, time, mass, pressure, current, force, power, and there are many others. These are just some few examples of what we call physical quantities, and they are very, very important to scientists. Types of physical quantities. Physical quantities can be base quantities or derived quantities. Now, when you hear the word base, what comes to your mind? Of course, words like foundation, fundamental, building blocks. So, in the place of base, we can equally say foundational physical quantities or fundamental physical quantities or building blocks of measurements. Base quantities are quantities defined by convention using a given system of measurement. These are quantities that cannot be derived from any other quantity. Derived quantities, on the other hand, are quantities which are obtained from two or more fundamental quantities. If we examine the definition given to base quantities, two main terminologies stand out, and that's convention and system. What is the meaning of convention? When we talk about convention, we generally means agreement between people on a particular matter. And in our context, the people here represent scientists. So long time ago, groups of scientists came together and used certain standards from which all other measurements are obtained. Have you ever asked yourself what duration of event was considered as 1 second? What quantity of matter was referred to as 1 kilogram? When we say 1 meter, what does it actually represent? Who made the decision of a given distance to be called 1 meter? Scientists came together and did it. So a group of scientists came together and used certain standards from which all other measurements are now obtained. So the definition of base quantity was by convention, by agreement. And this agreement depends on the system of measurement that was used. There are many, but there are three most widely recognizable systems of measurement in our world today. These three main recognizable system of measurement are the International System of Units, abbreviated as SI, which is the modified metric system. We have the British Imperial System and the US Customary System. The International System of Units, or the SI, is the internationally agreed system of coherent units used for all scientific and most technological purposes in many countries. When you hear of units like meter, kilogram, seconds, they were units that were defined under this system. The British Imperial System, on the other hand, is a historically used system of unit in the British Empire. It still applies today in some contexts in the UK and a few other countries. Units like feet, pounds, gallons, ounces, inch, yards are units defined under this system. The US customary system is mainly used in the US, and it is actually derived from the British Imperial System. Just that they have slight variations in the amount of matter that the unit represents. For example, a gallon, what they call a gallon in UK, is about 20% larger than what you call a gallon in the US. Among the three, the SI remains the standard system used by most countries for scientific and technical applications. And under the SI unit system, 7 base units are defined. And these 7 base units and quantities form one possible minimum set in terms of which all other physical quantities and units may be defined. So as you can see, these are the 7 base quantities, their units, and the symbols of the units. And students in high school are expected to master these 7 base quantities. Knowing them is the easiest way to distinguish between the base quantities or unit from the derived quantities or unit. This is because there are only 7 in number. as compared to derived quantities, which are many. So our next exercise is to find out whether you can use this table and distinguish between derived and base quantities. Exercise 2. Just like exercise 1 is a very simple one, there are just 2 questions. So I'm going to give you 30 seconds, and after which I'm going to come back and we figure it out together. Okay, time up. Answer for 1, of course, is A. Amount of substance is present on the table as a base quantity. It has unit mole. Volume, force, specific gravity are not found on the table and so do not represent base quantities. For question 2, the answer is of course D. Ampere and meter are base quantities, base units rather. Ampere and meter are base units. We've come to the end of our first lesson. In the next lesson, we're going to talk about units of derived quantities and transformation of units. And in that lesson, we are going to show how to obtain the SI unit of derived quantities from base units. And then we're going to see certain prefixes that are used in front of unit names and symbols, and how, when you're given such a situation, how you can transform the unit into a base unit. So this is the very first lesson that I've presented in this channel. If you are a high school student doing physics, I will encourage you to like, share, subscribe, and click on the notification bell to be reminded whenever a new lesson is dropped. I'll be uploading lessons at least twice every week. Thank you. This is Physics with Omia.